Legacy Savers, Marsh here. So today we're going to look at how can we prove parallel or quadrilaterals to be parallelograms using either just the theorems we know or also using some coordinate geometry today. So maybe going back to beginning of the year. How can we show a quadrilateral as a parallelogram using what we did yesterday? Well, there's a couple of options. One way is we can show that both pairs of opposite sides are parallel. What we're going to be able to use for that to show that is the slope formula. That's if we're given a couple of points of our quadrilateral. Show that both pairs of opposite sides are congruent. We're going to use the distance formula to prove that. And then show that the diagonals bisect each other. We're going to use what's known as the midpoint formula for that. And then we have a couple of other options as well. If both pairs of opposite angles are congruent, we can say it's a parallelogram. If one pair of opposite sides of the quadrilateral are congruent and parallel, so if one side is congruent and parallel to one another, and then if both angles of a quadrilateral are supplementary to both of its consecutive angles, that's also. If you need to do some writing here, slope formula, remember that, guys, was y2 minus y1 divided by x2 minus x1. That was the slope formula. Distance formula was d equals x2 minus x1 squared plus y2 minus y1 squared. And then our midpoint formula was x1 plus x2 divided by 2. That was our x-coordinate of our midpoint. And then y1 plus y2 divided by 2 was our y value of that midpoint. So first of all, let's take a look at just some general pictures and see if we can determine if the quadrilateral is a parallelogram. One thing I notice are our diagonals, right? They have been cut in half, so this piece is congruent with this piece, and then this piece is congruent with that piece. So that would mean that these diagonals are bisected, which tells me that yes, this is a parallelogram. And the reason for that would be that our diagonals are bisected. Okay? This one, notice we got sides opposite of one another congruent. Same thing going this way. So yes, this is another parallelogram. And sides opposite are congruent. So that's me explaining why they are the way they are. So now let's look at what if we have ordered pairs. So given the coordinates A of 0, 1, B is 4, 4, C is 12, 4, and D is 8, 1, show that the opposite pairs of opposite sides are parallel. Now remember, if we're wondering about parallel, we're wondering, are these slopes the same on both sides? So what we're going to do, let's first figure out where would this be like graphed, right? So A is 0, 1, so that would be a dot right here. B would be 4, 4, so that would be 1, 2, 3, 4, 1, 2, 3, 4. So that would be like right here. So this is A right here, this is B here. C would be all the way like past over here, but up here. And then D is 8, 1, so that would be like right here, probably. So that's my parallelogram right there. So now what I need to do is make sure that this side is parallel to this side, making sure that they're the same slope. So let's see what's the slope between AB. Remember, guys, slope formula, y2 minus y1 over x2 minus x1. So my y2 is 4 minus my y1, which is 1, over x2, which is 4, minus x1, which is 0. So I get 3 over 4. Let's see if CD has the same thing. So if it does, then I know those two sides are parallel. I can go 4, oh, hold on. Let's go 1 minus 4, right there. And then I will go 8 minus 12 down there. So this would be negative 3. And this would be negative 4. Well, a negative over a negative is in fact a positive. So they both do have the same slope, 3, 4, up 3 over 4. Let's see then if, change my pen color here. Let's see if BC have the same slope compared to AD. So BC, that would be 4 minus 4 up there, and 12 minus 4. So that'd be 0 over 8, which in fact just is 0. Let's see about A to D then. So that would be 1 minus 1 over 8 minus 0. So that'd be 0 over 8, which is in fact just 0. Notice, guys, how they are matching. So, yes, this is a parallelogram, and I have just proved it is by showing that the slopes are the same on each side. Now, let's try the other two ways we can do it. The other way, we can see if sides are congruent, which is, for this particular one, what you're going to want to do is the distance formula. Because you need to make sure that this side and this side are the same amount. So if I kind of graph this, so I can kind of get a visual representation, negative 2 comma 3, that would be negative 2, 3, so that would be like right there about. B is negative 5 sevenths, so that would be about right here, and then going up, so this would be B. C is 3 6, so that would be about right here. Whoopsies. And then D is 6 2, so that would be 6 comma 2, so like right here. There we go. So what I'm going to need to do is check to see what is the distance between A and B. Is that the same distance between C and D? So distance formula be x2 minus x1 squared plus y2 minus y1 squared. So let's plug in what we know, x2 being 7. So 7 minus 3 plus, oop, those are my x's, not my y's. Oopsies. Did the wrong one here. So I will go negative 5 minus a negative 2. Whew, almost messed up there. And then 7 minus 3 squared. Negative 5 minus a negative 2. Well, that's technically a positive, right? So then this is technically negative 3 squared plus 4 squared, which would be 9 plus 16, which is 25. So square root of 25. So this side has a length of 5. Let's try from C to D. So A to B, that's 5. I'm going to put a little note there. C to D, let's check that one. So I got 3 minus 6 squared plus 6 minus 2 squared. This would be negative 3 squared plus 6 minus 2 is 4 squared. So I do 9 plus 16. Hey, that's the square root of 25, which is, in fact, 5. So we do know that AB and CD are congruent. They are the same measure. Now, here's the fact, though. We do also need to check to make sure that BC and AD are also congruent. So I need to check here to here, and I need to check from, no, not A to C, B to C. And then I need to check from A to D. So I'm going to do the A to D part here. So we got distance equals D, so that'd be 6 minus a negative 2 squared plus 2 minus 3 squared. Well, 6 minus a negative 2, that's positive, so this would be 8 right there, so 8 squared, plus 2 minus 3, that is a negative 1 squared, which means I have the square root of 64 plus 1, because negative 1 squared is just 1, so square root of 65 seems to be that distance. And I'm just going to leave it as the square root of 65, because theoretically, B to C should give me the same thing. Let's try that one. So I have negative 5, 3 minus a negative 5 squared plus 6 minus 7 squared. So I have, well, that's going to become a positive, so that'll be 8 squared plus negative 1 squared. This looks very similar. So I got the square root of 64 plus 1, square root of 65. So I know that these two sides are congruent and those two sides, so this is in fact a parallelogram based on our math. And the last one, what we need to check for this one, show the diagonals bisect each other. What you're going to be doing is the midpoint formula. So if you remember that one, that was x1 plus x2 divided by 2. That was the x coordinate. And then the y1 plus y2 divided by 2 was your y coordinate. So if I kind of graph this up here so we can kind of get a representation in our mind. So that would be negative 3, 0. This would be A. Negative 3, 4 would be B up here. C is 3, negative 1, so that would be like down here. And then 3, negative 5, so D's got to be like down there. So what I need to do is I need to find the middle point of B to D and then the middle point of A to C. If that is equal, this is in fact a parallelogram. So we need to find the midpoint between B and D and the midpoint between A and C. Let's do my BD midpoint first. So I'm going to add my two x's together. So negative 3 plus 3 divided by 2. And set up my y's. That would be 4 plus a negative 5 over 2. Well, that's 0, right? Negative 3 plus 3, that's 0. So then I get 0 for that, because 0 divided by 2 is just 0. 4 plus negative 5, that's a negative 1. Divided by 2, that's negative 0.5, or negative 1/2. Let's check AC now. Let's see what AC's midpoint is. If it is the same, then we do have a parallelogram. So I have negative 3 plus 3 divided by 2, and 0 plus a negative 1 over 2. Negative 3 plus 3, that's 0. 0 divided by 2 is 0. Whoa, and then we get negative 0.5. Notice how these are matching. So in fact, I do have a parallelogram. So when you're working with a coordinates points and you want to see if it's parallelogram or not, you have three options. Either A, you can show that they bisect using the midpoint formula. You can use the distance formula, or you can also show that the sides are parallel using slope. And that's the end of this video. See you later, Sabers.